Hey everybody, my name is Marius and today I'll be starting a recording of a series of videos called the ABCs of NAT at the Aruba branch edge on CW7. Whoa, that's a lot to say. Okay, so effectively what I'll be doing is based on a couple of requirements and customers asking some questions. I've decided to maybe go and delve a little bit into this, right, and to look at basically the NAT. I thought it was going to be a quick 1-2 video series, just a couple of things just to show up. But after some investigation with the customers, what I found was that they got a little confused with terminology, right? How the terminology fits together and how this whole scenarios or the different scenarios can actually build up. So what I've decided to do then was basically go and delve into that a little bit and see if I could sort that out, obviously trying to sort out the problem. Then I came up with a little bit of an understanding that I wanted to do, so to show you. What I also don't want to do at the moment is, this is quite important, I think we've done enough, and I think most people, if you're looking at NAT, you know enough about netting. So what I'm not going to do, I'm going to write it down, is explain NAT, what it is, network address translation. I might refer to it. I'm not going to go there and build up the whole packet, the one device to the next device and how the actual translation happens. So I'm not going to do that. Yep. I'm not going to really jump into the why NAT. Okay, if you are sitting here and you're looking at this, you must probably have a reason to NAT. It's either security or it's IP address depletion. Okay, and it's up to you to make a decision of which ones you want to use, right, and how that affects your business. Right, I'm also not going to talk about most of the caveats, right, caveats of NATing. Things like security on multiple devices, when you NAT on one device, what happens to, I'm not really building into that at the moment, not for now. Okay, so this is not what I'm going to do. So not the basics. I know I call it the ABCs. What I do want to do, right, this is important, what I want to discuss, talking to the customers that ask me these questions, they all have a pretty fair understanding of NAT, why to NAT, and they also understand the caveats and basically the challenges around NATing and security. But where they do get stuck and they have issues is the terminology. Alright, so I decided to put something together very quickly and just do it in a whiteboard type scenario. You can always use the configuration guides. So these aren't my words that I'm using. It's what the HPE Aruba configuration guide looks like. All I try to do is I try and draw lines between them and just simplify it a little bit into a single page so that you can understand how it all fits together. Then I want to do basically is the how. Right, how do we do it? Well, first of all, how NAT is in itself seems to be a very simple thing. If you have a little home router, you have one IP address public facing, which is on one interface already being used, then the how is pretty simple, isn't it? It's pretty much facing to that one interface. And you NAT everything from the inside out. But in real life, that's not our typical customer that we do see. The how is a little bit more complicated. So I'll start with a how very simple version of home office, small office, home office, maybe something like a one IP environment. Maybe, we look at 5 IPs and how you could split them up and so forth. And this starts to move into a little bit of a branch, right? Branch type of scenario. So I might cover this in one video, I'm not too sure right now, I need to really look at timing. Okay, but anyway, so we'll start to cover these in videos. So video 1, most certainly today, is all about terminology. Alright, if you already know how to work with a Comware device, you should be able to pick it up from there with a configuration guide. However, if you want some examples, I will be putting some examples together. Maybe there's another 2 or 3 videos, around this. And then of course, at some point I really want to see how we can utilize the functionality of HPE/Aruba, some of the stuff they do like IRF, and see how we can bring this together. Okay, but that's for future videos. Right now, all we will be doing is look at the terminology. Good. Right, so this whole thing started off, like I said, with some people asking questions, and the majority of people asking questions had like a 5 IP environment, alright? So wanted to use one IP for the WAN interface, they wanted to use something like 2 IPs for their servers, for a dedicated service environment, and something like 2 other IPs for pretty much NATing. Okay, so that seems really simple and it shouldn't be that complicated. So let's first talk about the components of NAT. Like I said, I'm not going to drive too deeply into what is NAT, but there are certain components that we do talk about, and we have to get that terminology right. Okay. One of the challenges I did see talking to customers is that not everybody is quite understands the components of netting. So let's start with that. Components, right? And the first thing that we have is we have a NAT device. Okay, very important. Well, the NAT device is the function that holds the table. Okay, so that's the easiest way for me to explain that. Somewhere along the line, right, there is something that happens, right? There's a translation between our IP addressing, and that is a table that is then built up, and whatever device holds that table is the NAT device. The NAT device, which I'm not going to even mention here, is something that sits behind a NAT device. Now, this is something that gets very interesting if you look at things like ADVPN, an IPsec, and so forth. When they talk about a NAT device, right, you are behind a NAT device. It means that you are not actually doing the netting as a component. Brilliant. Okay, so the NAT device does the netting. Most important thing. Then a typical NAT device would be a router. Yep. And in our case, what we will be using is we're going to use the VSR. For now, I'm going to try and use the VSR as much as possible. Can't promise that's where it's going to stay, right? But I'm going to try and use the VSR with CW7. All right. So as an example, so that's the NAT device. The NAT, of course, the very next thing is that on that device there's multiple interfaces, which means that you have a NAT interface. The most important thing about the NAT interface, it is most probably the one that is connected to the WAN in most cases. Right? That's where you'll be doing the netting on the outbound interface. And this is where things already start to get a little confusing. Right? Because this is very interesting that I've seen, is when people start to build an access list, they don't quite know, should we use the internal IP address, or should we use the public IP address, or should we use a netted interface IP address? That's where things start to get a little blurry. All right, but if you think from a router's point of view, all right, you have to really keep your head around this of how the packet leaves the router, and that's important to know where the NAT interface sits then. Right, so from a NAT interface, you can see we can actually do netting either as inbound or as outbound NAT. Yep. Okay, so those are a couple of notes I wanted to make there. The very next thing that we do have, right, is something called a NAT address. I think this is quite important. I've started alluding to that just now. Right, and the NAT address is pretty much the public facing and the private facing. So if you look from a WAN point of view, a router connected to the service provider, a routable on the WAN public space IP address is the one that we're going to be netting to. Alright, the one on the inside is going to be private. This could be the 10, the 192s, the 176, whatever the case may be, your private IP address ranges. Okay, and there's multiple reasons to NAT, because you could have overlapping NAT addresses or IP addresses and so forth. Right, but remember that we typically talk about a private space and a public space. We will NAT private to public, which effectively says that anything from this router forwards does not need to know about this in its routing table, right? It doesn't have to care about anything behind this router. So there's multiple good reasons to NAT. Good. So that's the NAT address. We'll be looking at the private versus the public. And then, of course, I think the most important thing is NAT entry. Brilliant. So from a NAT entry point of view, this is pretty much a combination of the above. A NAT entry lives on the NAT device. It's a combination of the above. So it lives on the device. I always want to say it's contained in a table. Yep. So the table is on the NAT device. It's referring to a specific interface inside the table. Right? It talks about the addressing, the private, NATed to the public. Right? This NAT entries could be a couple of things. The first thing that it could be is a NAT session entry. This, I think, is the simplest form of a NAT entry. Okay, so it's effectively IP address to IP address entry based on interface configuration and based on an actual device. But there's also something, this is typically in a one-to-one type NAT environment. There's also something that we'll talk about, and that's something called PAT, right? Port address translation. This is when you have a many-to-one environment. So if you have lots of devices, right, talking with the same public IP address, you can't do a one-to-one NAT anymore. So it's not a simple NAT session entry, you know, one-to-one. 10.1.1.1 natted to a public IP address of 123.1.1.1. Okay, in that case, you only have one public. Then we start doing the port addresses. We start using ports. Okay, and in this case, what they call it, right, in the HP environment is an EIM entry. An endpoint independent mapping entry. I know in other vendors, they talk about this as PAT and so forth, but this is an EIM. That's one of the first things I want to talk about, the terminology. Right, EIM entry. You'll see it during the actual configurations as well. Then after that, so this is pretty much a PAT entry, port address translation. So that's an extension of the NAT session entry. It's a little bit more information. It also takes a little bit more time to figure it out, and it also takes, of course, a little bit more resources to maintain this. But the nice thing about this is it's a great example where we actually do something like this, where we NAT, right, multiples to one. But there might be a scenario where you're saying to yourself, well, I don't really want to have a full-on multiple to one. So in this case, I only have two NATed IP addresses available. I only want the concurrency of two devices ever. So let's talk about environment there. I might have, let's say, 4 servers, but only 2 of them can talk concurrently at a time. We can also have a port address translation environment as well. And then we talk about a no PAT entry. Okay, now this is where things get a little bit interesting. There's some good reasons for that. I'll show you in configuration later on, hopefully, if we get to that. All right, not today, but in future videos, of where to use a no PAT type environment, all right, and when to use it. So those are pretty much the 3 environments. It's a one-to-one, it's a many-to-one with EIM entry, and a no PAT is also a many-to-one, but only one-to-one at a time, concurrency ratio. If that makes sense. Yep. Okay, so those are the components of a NAT environment. The second type that I want to talk about, let's change color just because we can, okay, is the types of NATing. Now, what's important for you to know is that when you have a NAT environment, you're going to look at the components required. You're going to look at, very important, the entries. Now, why do I say that's important? Because at some point, the deeper you go here, the more you go into this, the bigger the tables, okay, the bigger the environment, the higher the component device you need, the bigger the router. Does it make sense? Yep. Good. Okay, so one of the interesting things is that the VSR actually does really well in NATed environments, right? Because it actually holds a lot of RAM on the server-like environment, and that means it's good for table sizes, and it's really good at looking up tables, you know, and IRS type environment. So this is brilliant. Okay, so that's why VSR is a great example here. Okay, so from a TAP's point of view, we have a traditional. Just bear with me. We have traditional NATing. Now, traditional NATing is where we don't do anything funny. Okay, we've got an outside, we've got an inside, a private, and a public. We take inside addresses. Now, this is not simple NATing. I'm talking about a traditional NAT where we're taking private addresses, we NAT them on an interface outbound, and as the packets come back in again, it's matched against the table, and that packet is translated back to the private address and fires into the router, into the environment. Yep. So that's traditional NATing. Okay, then you get something where we say, well, maybe we don't quite want just traditional NATing, we want bidirectional. So we don't just NAT in one direction. Okay, an environment like that is typically, I'll just draw it over here because I can just quickly rub it out. Okay, or let's jump to the next page, I can just use that. Okay, so for bidirectional NATing, typically what you're saying is that you have, let's say, an environment, These are connected with a 1.1.1.0 type network, and you have a 10.1.1.0 network here, and you have a 10.1.1.0 type network here. Okay, and what you want to do is you want to basically NAT traffic coming from here. So you want to NAT this 10.1.1 into this environment, because if a PC sits over there and it pings, let's say here's .100, and this is .1, and this is also .100, doesn't really matter, but let's keep it simple. Let's make it 1, 2, 3, right? If he pings 10.1.1, 1, 2, 3, he won't send it to default gateway. Yep. So there's got to be a NAT somewhere. So he's going to be pinging something else. He can't ping 10.1 to get to this guy. Okay, so he'll be pinging some type of NATed address, right? Which could be, let's say, 172.123.1.1. Okay, and somewhere this guy's got to build a NAT table for that. Traditional NATing. So that goes this direction, he gets to him and he says, oh, well, to get to that, I have to go to an IP address. But look at this now. Suddenly he goes, wait a moment, 10.1.1 is left. Okay, so this is where we start to move into bi-directional NATing. Okay, we start to look at things like that, where we say, oh, okay, fine, we still have to get to it somewhere else. So how do we do that? Well, that's bi-directional. Okay, so it gets a little bit more complex in this, and that's where we want to talk about the bi-directional. Okay, I'm not going to go into the configurations right now. What I want to do is I just want to talk about the why would we have something like that. So bi-directional NATing already gets a little bit more complicated. It's not typically from a inside network to the WAN. Those are more VPN type scenarios. We have VPNs and so forth. Right. Then you get environments also commonly seen in VPNs as well is twice NATing. Okay, this is when you NAT one packet twice on its route. Okay, there are lots of good reasons for that, to use twice NATing. Once again, typically in a VPN type environment, right? So once again, you've got to think about this. Do you need a twice NAT environment? And if it is already being NATed twice, the router, the device, needs to be clever enough to figure out that there is two NATs sitting behind it. All right. So that is different to bi-directional NATing. And twice NATing, of course, is when one packet gets NATed twice. Right. And bi-directional is when a packet gets NATed into both directions. Right. This is one direction, and these are two directions, in and out, and this one is just out but twice NATed. Okay. Then they have something called a NAT hairpin. Okay. Now, this is interesting. NAT hairpin. Some of you might actually recognize this. All right. Hairpin. Oh, sorry about that. Gee, this is me kicking in today. Okay. Let me just grab that again. Okay, so from a NAT hairpin point of view, what we have is there's two types of NAT hairpin. I'll explain what that is just now. You get a point-to-point NAT hairpin, and you get a, no, not point to multi-point, you get a CS hairpin. Okay, let's quickly talk about that. I'm going to jump into the next slide again. This is a scenario, very interesting, where you have, let's say, a server, but you don't have multiple interfaces. So you actually have a router, right? You've got a WAN type interface, service provider type interface, so this is more your WAN type interface, and you've got an inside network, but you want to actually go and host, let's say, an FTP server here. Okay, but you also have clients. This is all one IP address range, so 10.1.1.x. Okay, .100.101, and let's say this is .254.1 scenario. Okay, so when somebody comes from the outside in, they want to be able to access the FTP server. It's not for the clients right now, just for the clients, it's from the outside in as well. So what you'll do is you'll do a one-to-one type NATing, normally for them, so they can get in. So with a one-to-one type NATing, what you'll do is you'll have a WAN IP. So let's call the WAN IP for now 123.1.1.0. Okay. So what we do is we go and NAT 10.1.1.254 to, in the NAT entry, 123.1.1. Let's call it 254 for now. Okay, we know that this is an FTP service, and that's what we announced to the world. Okay, so for somebody coming from the outside in, they would FTP to 123.1.1.254. And what happens is the NAT happens, or natting happens, and it goes to the IP address. Okay, everything simple so far. Nothing, that's traditional natting, one-to-one. Okay, what we do now is, which is different, is we don't get these guys, the clients here, to FTP to 10.1.1.254. No. What we say to them is we want to FTP to 123.1.1.254. And what happens is they will then basically connect to this FTP server through a hairpinning through the router. Interesting. Okay, that brings a lot of security into play. So they can't directly access the FTP server, they have to go through the router. And there's a lot of reasons we want to do this. Now this is the CS environment, C/S environment. Okay, the point-to-point environment is when they actually have a server, a device there that registers IP addressing. So before this guy can talk to anybody, he registers IP address with him, right, a NAT IP address. And before he can talk to anybody, he can only talk to the NAT IP address of this device. So what you find is that all traffic happens through the router. Interesting. Okay. So that is the point-to-point scenario. I'm hoping to do a video on that because that's quite interesting that I saw so far. Okay, so definitely want to do a video on that one. So that's the point-to-point in the CS environment. That's NAT hairpinning. Finally, just before you lose hope and think, what are we talking about? Or maybe you're getting excited about the complexity here. We've got something called EasyNet. Okay. EasyNet. Now, EasyNet is a typical environment where you have one IP address, all right, and you want to really just quickly set it up. I'm at my home user, as a home user, I've got WAN connectivity, and I've got an IP address on this interface, and that's the only IP address, public IP address I've got. Also, the other thing is this IP address keeps on changing every now and then, you know, based on DHCP, whatever the case may be. And I've got an infrastructure inside here. As a matter of fact, I've got a couple of infrastructures in here, right? But it doesn't matter. Most of them want to get to the WAN environment. And with Easy IP, what I do is I don't create a pool of addresses and X, Y, Z. No, that's not what I do. What I do is I literally just point it to the interface and put natting on that interface. So anything leaving this router through that interface will be natted. It's a very fast, efficient, and nasty way of setting up natting. Boom, quickly. Alright, if you need nothing else. Good. So that's EasyNet. It's based on, if I almost want to say, it's based on the interface. Of course, you know where I'm going with this, yeah? This will be video 1. We want to start with something easy, not that complicated. Okay, so sorry about that. Then we've got something called NAT translation control. That's the inverse of EasyNet. Whenever you say, I've got something a little bit more complicated environment, I'm going to do NAT translation control. Right, this is where I want to control pools of addresses going different places and so forth. Now the way I see this is you could have combinations of traditional and easy, you could have combinations of twice and NAT translation control and so forth. But it's important to understand that these are the types of natting that you'll see in the configuration guide. Okay, just want to get some space here, so let's just rub this out a bit, get some more space here. Okay, so that's the types that we get. The NAT implementation is next. So let's change color. Let's go to white this time. Okay, then we've got something called NAT implementation. Yep. Sorry, I'm running out of memory. Implementation. Okay, so the NAT implementation is how do we implement, you know, based on a device, a specific type of natting. Well, I think the most important one is the static NAT. Now with static NAT, that is a one-to-one environment. So I've got, let's say, 10 private addresses, NATed to 10 public addresses, and it's static, which means I say address 1 goes to address 1, 2 goes to 2, 3 goes to 3. Nice thing about this is that it's very predictable, and the most important thing about static NAT is that when people want to come from the outside in, let me just show you there. Okay, one of the challenges of NATing, sorry about that, if you have a router environment and you have a let's say this is the WAN environment, right, and this is the LAN environment, LAN, right. When this guy moves through this router, he comes from a 10.1.1.x network, doesn't matter, and it then translates to a WAN interface. So the person sitting on the other side of this server, whatever the case may be, sees only this IP address with a port, and he responds to that. Okay, so one challenge for the server is you cannot have a 10.1.1 address on the inside. So how do you solve this? Well, you can do one of two things. You can turn around and say, well, I can't use 10.1.1 there because it's a private range, which means it's non-routable on the internet. Okay, so give it a 123.1.1.1 IP address here. But that leaves me with a bit of a challenge. One of the reasons we do NATing is because of the IP address depletion that we have with IPv4. By the way, it's been going for 20 years now. But anyway, we can't do that. There's not enough IP addresses going around. Because how do we assign ranges? And that's the challenge. You can't just assign 1 or 2 IP addresses and so forth. So this is normally not possible. And if you're large enough as a company, then you'd have this. Right. Another reason for using this, even if you had enough IP addressing, is to do security, to hide away some addressing, so people can't just get into your network and guess it. Okay, so I want this to be a 10.1.1 network, but the challenge with that is then how do I get the server to connect to you if he needs to get into this network, if this is another server. Okay, so from the inside out, no problem with NATing. From the outside in, it's this guy can't predict. He wants to go to an FTP service, right, on an IP address on a certain port. And that's why you have certain internet facing services. Okay, so in that case you have no option but to go into a WAN table here and create one public IP and you NAT it to some type of private device IP. Okay, so we can either do it based on IP or we can do it on host name. We'll talk about that just now as well. Okay, so from the outside coming back in again. This is a great example for the way to do NOPAT, this host name. Okay, brilliant. So we do need static NAT, like we've said before. Right, and there's a very good reason for that. When you saw the 405 IP example, 2 of those could be static NAT from the outside in onto your server. Brilliant. So that's very important. But what we need to know is that this is a 1-to-1 ratio that we use. Then, of course, the very next thing that we would have is something called dynamic NAT. I'm not going to write the whole thing out. Anyway, dynamic NAT. In this case, it is a many to 1. Okay, so effectively, immediately when I say that, there's 2 options that we have, which is PAT and no PAT. In this case, from a NAT implementation point of view, you'll see that they talk in the configuration guide about PAT, and here they talk about an entry of an EIM entry. They are connected to each other. Okay, so this guy here and this PAT here is the same thing. That PAT entry is actually an EIM, endpoint independent, right, entry. No PAT, you'll see there no PAT as well. So that's basically how do we do the dynamic NAT at the moment. Right, that's the second option we can use. So, like I said before, this is now to start off with. Let's just get some space here to get this working. We either have a static NAT, dynamic NAT, and then you'll see they also talk about the NAT server. Right. NAT server. Now, under the NAT server, this is pretty much a host public server. This is what you want to do. When you host a public server, I'm running out of memory. Okay, so there's the public server, right? In the case like that, and you want to do something like load balancing. That's when we set up the NAT server. Okay, this is where things get, because you would say to me, well, host a public server, that's a static NAT. But if you want to do something like load balancing, it's slightly different. What I'm going to do is I'm going to put 5 FTP servers on the inside, all right, on my private space. So 10, 1, 1, 1, 2, 3, 4, and 5, and I give it one public IP address. That's seen in the actual Aruba / HPE networking environment as a NAT server. That's the first environment. All right. So I can base this NAT server and load balancing, whatever the case may be, I can base this, and as I said before, either on IP address, or I can base it on host name. And this will be some type of port mapping, right, that it maps to ports and so forth. Right, and that is effectively, you know, the terminology around this. So in the following videos that we're going to be making, you'll see what we're going to do is we're going to start off with, you know, simple stuff. And most probably the one video I want to make first, let's mark that maybe as a different color there, all right, is something like the Easy NAT. This could be a video here, right? Easy NAT, I think, could be one of the videos, because I want to have a really quick, fast way for the majority of people how to get this going. Then I want to do a combination of maybe something like a static NAT, you know, somewhere in a video along the line, moving to dynamic NAT. Now you'll see static NAT and dynamic NAT is a combination of this as well, all right? And like I said, I'll do that on the VSR, and depending on the environment that we do get. So if you want to see specifics, let me know, you know, in the comments field. Maybe we can look into them, because this is an ongoing series of videos, depending on how the customers, you know, require information. Then somewhere along the line, I definitely want to mess around a little bit with the NAT server, and more importantly, if I can mess around with the NAT server, you know, is to look at something like the load balancing. That would be very interesting, you know, to see something like that happening. Good stuff. So in the future videos, like I said, you'll always see the series of videos that I do start. I normally start with the terminology or explanation of the components. My next videos would be actually configuration videos of these. So watch this space, and hopefully soon you'll be seeing some configuration videos coming through. Okay, thank you very much for your time. I really appreciate that. And if you do like these videos, please give us a like. Right, if you have comments about these videos, please do comment. And if you have an account with YouTube, please don't hesitate to subscribe. All right, because by subscribing, we do upload a lot of videos, you know, and there are a lot of topics. It's a very interesting or easy way for you to follow what we're doing. Now, you don't always have to come back and see what we've done. Right, it's more a heads-up environment. Okay, and with that, I want to really thank you for your time, and have a great day. Cheerio. Bye-bye.